Hello all. So let us look at few more problems on evaluating the double integral. So the first problem is to use a double integral to find the volume of the solid that is bounded above by the plane z equal to 4 minus x minus y and below by the rectangle r equal to 0 1 cross 0 2. So here x varies from the line x equal to 0 to x equal to 2, and uh, so we have x equal to 0 to x equal to 1, and this is y equal to 0 to y equal to 2. So that's how the region looks like in the xy plane. Now in the yz plane you'll be having curve like a surface like this. Okay, so that will be passing through the points. So we have z equal to, so we have z plus x plus y equal to 4. So it will pass through the point 0 0 4. So this will be so this surface will intersect the z axis at the point 0 0 4 and x axis at the point, so 4 0 0, and y axis at the point 0 4 0. So that is how your surface is looking like. അപ്പോൾ നമുക്ക് ഒരു പ്ലെയിൻ ആണ്. ഇനി ആ പ്ലെയിനും ഈ റെക്ടാങ്കുലർ റീജിയൻ ആണ് എക്സ് വൈ പ്ലെയിനിലുള്ളത്. അതിൻ്റെ ഇടയ്ക്കുള്ള വോളിയം ആണ് കണ്ടുപിടിക്കേണ്ടത്. ഓക്കെ, സോ ബൈ ഡബിൾ ഇൻറ്റഗ്രൽസ്, so volume will be double integral over r f of xy dA. So dA will be the integrand, the order of integration. So that is either constant limit ആയതുകൊണ്ട് നമുക്ക് ഒന്നെങ്കിൽ dx dy എടുക്കാം അല്ലെങ്കിൽ dy dx എടുക്കാം. Okay, so this will be double integral 4 minus x minus y. So let me take dx dy. So first here the inside first integral is with respect to x. അപ്പോൾ x ന്റെ limits എഴുതുക. So that is 0 to 1. Then you have the limits for y, which is 0 to 2. Now first integrate with respect to x. So we will get integral 0 to 2. When you integrate with respect to x, you will get 4x minus x square by 2 minus yx from 0 to 1 dy. Now apply the limits. So we will get 4. Apply the limits on x. So 4 into 1 minus 0 varum, minus 1 by 2 into 1 square minus 0 square minus y into again 1 minus 0 dy. So that is integral 0 to 2 4 minus 1 by 2 minus y dy. So that is 7 by 2 y minus y square by 2 from 0 to 2. So that is 7 by 2 into 2 minus 0 minus 1 by 2 into 2 square minus 0. So we'll get 7 minus 2, which is equal to 5. So the required volume is equal to 5. To evaluate integral 0 to 2, integral 0 to 1, y cos x dy dx. So first you need to integrate with respect to y and then with respect to x. Now when you integrate with respect to y, cos x will be constant. So we'll have cos x in y in the integral y square by 2 varum from 0 to 1 dx. So that is integral 0 to 2. So we'll get 1 by 2 cos x dx. So the integral of cos x is sin x. So we'll get 1 by 2 sin x from 0 to 2. So that is 1 by 2 sin 2. So that is the required value of the integral. Problem is to evaluate integral 0 to 2, integral 0 to 1, x by xy plus 1 whole square dy dx. So first we need to integrate with respect to y. So x will be considered as constant. Now this is in the form 1 by ay plus b whole square. ഇനി 1 by ay plus b whole square ന്റെ integral എന്ന് പറയുന്നത് that will be equal to minus 1 by ay plus b into 1 by a വരും. So here the integral of 1 by, so when you integrate with respect to y, x will be considered as constant. So the integral is going to be minus 1 by xy plus 1 into 1 by x. So the value of y varies from 0 to 1 dx. ഇനി ഇവിടെ x cancel ആവും. So we'll get integral 0 to 2 minus 1 by xy plus 1 from 0 to 1 dx. Now apply the limits on y. So we'll get integral 0 to 1 minus 1 by x plus 1 minus, now when you put y equal to 0, നമുക്ക് minus 1 കിട്ടും. So that is integral 0 to 1 minus 1 by x plus 1 plus 1 dx. So the integral is minus ln of x plus 1 plus x from 0 to 1. So that is minus ln 2 plus 1. Now at 0, both the values are 0, so the required value of the integral is minus ln 2 plus 1. There is a small correction. So here the limit was 2. Okay, so ഇവിടെ എല്ലാം 2 വരും. So when you apply the limits from 0 to 2, you are going to get ln 3 plus 2. So the answer is minus ln 3 plus 2. The problem is to evaluate integral 0 to ln 2, integral 0 to 1, x, y, e raised to y square, x dy dx. So first we need to integrate with respect to y. So when you take the function with respect to y, so you have y. So y വരുന്ന terms എന്ന് പറയുന്നത് y e raised to x y square. So when you take the derivative of e raised to x y square with respect to y, so we are going to get 2yx e raised to x y square. So when you integrate y e raised to xy square, that is going to give us e raised to xy square by 2x ആയിരിക്കും നമുക്ക് കിട്ടുക. Okay. So let us write down the first integral. So when you integrate with respect to y, so x will be considered as constant. So integral of y e raised to x square, e raised to y square, x will be e raised to y square x by 2x വരും. So apply the limits from 0 to 1 upon y. So here x will cancel off. So we will get integral 0 to ln 2 1 by 2. Y യുടെ limits apply ചെയ്യുക. So we will get e raised to x minus e raised to 0 is 1 dx. So that gives 1 by 2 e raised to x minus x from 0 to ln 2. So we will get 1 by 2 e raised to ln 2 minus ln 2 minus e raised to 0 is 1. So that gives 1 by 2. Now e raised to ln 2 is equal to 2. 2 minus 1, 1 varum. So we will get 1 by 2 into 1 minus ln 2. Next problem is to find the volume under the surface z equal to 3x cube plus 3x square y, and over the rectangle r equal to set of all xy such that minus 1 less than or equal to x less than or equal to 3 and 0 less than or equal to y less than or equal to 2. So by definition, volume will be double integral over r f of xy dA. So that is double integral. So let us integrate first with respect to y, then with respect to x. So we'll get 3x cube plus 3x square y dy dx. So that is integral minus 1 to 3. So we will get 3x cube y plus 3x square y square by 2 from 0 to 2 dx. So that is integral minus 1 to 3. So we will get 6x cube plus now 2 square by 2 വരെ ഇവിടെ limit apply ചെയ്യുമ്പം, so that again gives 6x square dx. Now let us integrate this function with respect to x. So that will give 6x raised to 4 by 4 plus 6x cube by 3 from minus 1 to 3. So that is 3 by 2. Apply the limit, so we'll get 81 minus 1 plus 2, 27 minus 1. So that is 3 by 2 into 80 plus 2 into 28. So that is 120 plus 56. So we get 176. So that is the required volume. Problem is to find the volume in the first octant bounded by the coordinate planes, the plane y equal to 4 and the plane x plus x by 3 plus z by 5 equal to 1. So let us look at what is the region you obtain in the xy plane. So we have the region in the first octant that is bounded by the coordinate planes. So the coordinate planes will be x equal to 0, then we have y equal to 0, then it is bounded by y equal to 4. In the first octant z will be equal to 0. അപ്പോൾ നമ്മൾ xy plane എടുക്കുമ്പോൾ on the xy plane z is equal to 0. So z equal to 0 will give x by 3 equal to 1. അതായത് നമ്മുടെ പ്ലെയിൻ എന്ന് പറയുന്നത് ഈ എക്സ് ബൈ 3 പ്ലസ് സെഡ് ബൈ 5 ഈക്വൽ ടു 1. അത് എക്സ് വൈ പ്ലെയിനിൻ്റെ മേളിലുള്ള പ്ലെയിൻ ആയിരിക്കും. എക്സ് വൈ പ്ലെയിനിൻ്റെ മേളിലും താഴെയും വരും. ആൻഡ് ഇറ്റ് വിൽ ക്രോസ് ദി xy, it will intersect the xy plane when z is equal to 0. So that is going to intersect along the line x equal to 3. Okay. So x equal to 3 intersect ചെയ്യുക. So our region is bounded by x equal to 0. അപ്പോൾ ഈ എക്സ് വൈ പ്ലെയിനിൻ്റെ പോർഷൻ ആണ് z equal to 0 എന്ന് പറയുന്നത്. അപ്പോൾ നമ്മുടെ കോർഡിനേറ്റ് പ്ലെയിൻസ് എന്ന് പറയുന്നത് x equal to 0, y equal to 0, then you have z equal to 0, and you have a plane y equal to 4 which is bounding the region. Then x equal to 3 ആ സർഫസ്, അതായത് എക്സ് ബൈ 3 പ്ലസ് സെഡ് ബൈ 5 equal to 1 meet ചെയ്യുന്നത്. So this is the rectangular region you are getting in the xy plane. So therefore in the xy plane the rectangular region is bounded by planes is so that will be 0 less than or equal to x less than or equal to 3 and 0 less than or equal to y less than or equal to 4. So therefore the volume will be given by, so from here we have z by 5 equal to 1 minus x by 3. So that implies z will be equal to 5 into 1 minus x by 3. So this is going to be your f of xy. So that is double integral z dA over the region R. Z in the value will substitute here. So that is 5 into 1 minus x by 3. So volume will be double integral